beautiful PU1 students. So here we come up with the fixed questions. So yes, 2 to 5 marker, 1 marker, everything is covered. Here I am going to tell only the fixed question. Remember, no numerical. Yes, a few little bit very important numericals I kept here, but majority of the numerical, if you want to learn, please watch the 2 to 5 marker video. I guess your concept will be cleared out there. There in that video you will get more clarification about how to write the answer and what will be the exact answer. So I guess that will be a perfect last minute revision video in case you have not started studying. Yes, so yes, let's discuss a little bit fixed question about your syllabus. So yes, here comes some basic concepts of chemistry. You can see most important question if you ask me, even in your model paper, and if you see the last previous year question, then also you can see the most important thing is molecular formula and empirical formula, the relation between them, okay, and the question related to limiting reagent. And one question, it is a numerical problem that I kept here. You have to find out the molecular formula and empirical formula. This type of numerical problem you can expect one, and one more type of numerical, that is about the relative abundance. Okay, so please don't forget to do them. Let's proceed with the atomic structure. So here comes the most probable questions out of that chapter. These are all theoretical questions. Again, I'm telling you, for the numerical problem, please do watch that video, 2 to 5 marker. There I have covered chapter wise all the numerical problems. Okay, don't forget to go through the numerical related to the Heisenberg's uncertainty principle, the problems related to de Broglie's hypothesis, the problems related to E equals to H nu. Okay, there's so many problems we did. Okay, let's proceed. Periodic table, here comes the question. You can see ionization energy. So be careful whenever you are mentioning about you are defining ionization energy, don't forget to write about the isolated gaseous atom. It's a very important terminology for anything like ionization enthalpy, electron gain enthalpy, whatever you are writing, please make sure that you are mentioning this term. Okay, and ionization energy related term questions, it's very important over here. As you can see, boron is less, boron is having less ionization enthalpy than that of beryllium. Why? This type of question is important. Okay, and rest of the things you can see from here. If you want, again I'm telling you, if you want proper answer, the clarification with answers, then please do watch that video. Chemical bonding, here comes the sets of question. Limitation of octet rule, VAC pair theory. Okay, VAC pair theory postulates are very important. For few compound you have to explain with respect to the VAC pair theory, like a BeCl2, CH4, NH3, H2O, like that. Okay, hybridization is very much important. In hybridization you have to explain, you may have to explain acetylene, SF6 molecule. Okay, and for MOT, C2, N2 and O2, all the three you should go, you should proceed with. The conditions of LCAO means linear combination of atomic orbitals, that also you have to proceed with. Yes, this is another question zone, that why the bond angle of SO2 molecule is 120 degree, lesser than that of 120 degree. Okay, why the bond angle of water molecule is 104 degree. So this type of question they can ask. The question related to the dipole moment also can be asked, like with respect to NH3, NF3, okay, BF3. Okay, so be careful about it. So another one important question, that is helium, why He2 does not exist. Okay, so these are the question zone. Next, thermodynamics, definitely it's a numerical based chapter. The numericals are covered in that 2 to 5 marker video. Here one very important numerical, I have seen it coming multiple years, even in the model paper it was mentioned. So that's why I kept this type of numerical here. Don't forget to do this. Along with that, these are the theoretical question. You can see derivation can come, Cp to Cp minus Cv equals to R, that derivation can come out of it. Gibbs-Helmholtz equation, where del G equals to del H minus T del S, that type of thing. And basic, like first law, what is free expansion, enthalpy of fusion, enthalpy of atomization, this type of thing you can expect. These are the theoretical question. Again, I'm telling you theoretical questions only I'm telling here. Okay, let's proceed. Equilibrium chapter, it's a very important numerical based chapter, so don't forget to watch the numerical that I covered in that video. Okay, so yes, beside that, few theoretical portions are also there that are also covered. You can see application of equilibrium constant, how to predict the direction of the equilibrium with respect to reaction quotient and equilibrium constant, Le Chatelier principle, direct statement that can be asked, effect of pressure, temperature, concentration and addition of inert gas. All four are important. Any one can be asked. Okay. Next is you can see conjugate base of any one of the species can be asked. Okay, this type of question, why this is Lewis acid, why that is Lewis base, this type of thing can be asked. This is the derivation based, pH plus POH equals to 14, that you have to show. Common ion effect, buffer solution, very important. All the example, acidic, basic and neutral buffer example they can ask. Henderson-Hasselbalch equation, very important. These are the theoretical question. Again, I am telling you. So, for the numerical, make sure you are watching that video. Yes, let's proceed. Redox reaction, these are the basic question. Very few questions comes. Selectively, we can predict the question. In fact, oxidation state they can ask. Stock notation they can ask you to write down. And any type of redox reaction related question, disproportionation type, this type of question they can ask. Balancing a reaction is very, very important, majorly in half reaction method. Okay, so iron 2 plus oxalate, iron 2 plus MnO4 plus MnO4 minus, these examples are very common. Please make sure that you are going through them. Okay, proceed. This is organic chemistry, GOC. Basic nomenclature, very, very difficult they will not ask. Very, very basic thing they will ask actually from the nomenclature portion. Bond line structure they may ask you to draw. They may ask you, like they will give you a compound condensed formula. They will ask you to count the sigma and pi bond out of it. Okay, in isomerism they can ask you to like write the definition of functional isomerism. Very high chance to ask you the metamers. Okay, positional isomers, you can expect the MCQs out of it. Okay, difference between electromagnetic effect and inductive effect in individual definitions are also important. Numerical problem comes from this chapter, from the Carriers method. In the model paper also one numerical was mentioned from the Carriers method. Okay, Dumas methods are also important. Okay, sometimes they ask this type of small question, like in Jedal's method, what is the species that cannot be identified. Okay, this type of thing you remember. Separation technique, basic separation technique, they can ask you about the instrument, or they will give you the mixture of two certain compound, in which process you should separate this. This type of question you can expect. Okay, let's proceed. Hydrocarbons. Okay, hydrocarbons are sets of questions are there. You can see Wood's reaction. Okay, basic reaction, this is boiling point related question. With atomic mass, why it increases, with branching, why it decreases. Okay, next, chlorination of methane, it's a 3-marker question, very important. Initiation, termination, initiation, propagation, termination. 3 steps you will mention for 3 mark. Okay, next you can see aromatization reaction. What is cracking? Cracking is also important. Polymerization is also important. Sohor's and Newman projection of ethane, very important. You have to draw the structures over here. Okay. Preparation of alkenes from alkynes, here cis and trans, both of them you have to explain. Next, dehydrohalogenation. Next, Markovnikov rule, with example you have to tell. Okay, proper statement and along with that example. Okay, so electrophilic substitution, you have to proceed with nitration and sulfonation, very important. Okay, halogenation also you can check once, but nitration sulfonation is very important, highly important. This is electrophilic substitution in benzene. The entire mechanism is important. Okay, so yes, this is all. This is a fixed question from all the chapters. Again, I am telling you, this is only the theoretical portion. For further numerical portion and even more detailed explanation, answers, please do watch the 2 to 5 marker video along with the PU1 model paper, and make sure you are liking, subscribing and sharing this video. Thank you so much for watching.